Math 2, lesson 8.2, we're going to talk about area of circles and sectors. Okay, this is very similar to yesterday. When we are finding our length, we were using the circumference. When we're finding the area of a sector, so it's like taking the area of like a piece of pie. We know our area formula is pi r squared. Okay, we're doing the same type of thing today, but we're going to be using our area formula instead. Okay, so if you were given your diameter, like for this got it problem, it says what is the area of a circular wrestling region with a 42-foot diameter? So how do we get the radius from the diameter? Good. So our radius is the diameter divided by 2, and so 42 divided by 2 equals 21. So plugging it into our area formula, area equals, I'm just going to do 21 squared times pi, kind of a different order there. You can write it however you want to. In your calculator, if you type in 21 squared, you get 441 pi. And this is feet. This is feet squared. You actually have to have a pencil out in order to actually take notes. Okay, and then you have to like put it on your paper. Okay? Crazy. When you're doing area, okay, you're multiplying feet times feet, which is why you get feet squared. We're multiplying 21 feet times 21 feet. Okay? So it's 441 pi feet squared. Or if you typed in 3.14 times 441, okay, it is approximately 1,385 feet squared. Because if we're actually talking about the feet on a mat, I wouldn't keep my answer in terms of pi, okay? But either one of these answers is acceptable. Okay, questions so far? Okay. Does anybody have questions for me? All right, number 1. Looking at this circle. Some of you see fractions and you get scared. Do you know what, if this diameter is 2/3, what would be half of that? 1/3. Now, most of you, oh my goodness. Stop talking. Most of you in your head can figure out that the radius is 1/3. Okay, because if you have 2/3, you would split this up 1/3 and 1/3. And if you add 1/3 and 1/3 together, you get 2/3. The long way, if you had a fraction that you couldn't just cut in half, okay, you would take 2/3 and you would divide it by 2. What do you do when you have a fraction like that with division? Very good. So you'd end up getting 2/3 times 1/2. See here how the 2's cancel out and you end up with 1/3. We good? Bless you. Okay, so to find the area of this, okay, area equals pi r squared. So area equals, we have 1/3 squared times pi. Does it matter if I have the pi in the front or the pi in the back? No. Okay. The reason why they write pi in front here is that pi actually represents a number, and you should always have a number in front of your variables. Okay. So when I'm working here, 1/3 squared is what? So whenever you're squaring a fraction, you square the top number and the bottom number, your numerator and your denominator. So what is 1 squared? 1. What is 3 squared? 9. So we have 1/9 pi, and then because this is inches, it will be inches squared. This one said to leave your answer in terms of pi, and so that is what I'm doing. Okay, are we good? Question? That's fine. Normally though, when you start a problem with fractions, you normally end it with fractions. But I would accept either answer. Okay? Anything else? All right, number 2. Okay, agriculture. Some farmers use a circular irrigation method. An irrigation arm acts as the radius. So we know we're talking about a circle. They're telling you that the irrigation arm is a radius. Okay, so that's what we're dealing with there. So it acts as the radius of an irrigation circle. How much land is covered with an irrigation arm of 300 feet? So they're telling you the arm is 300 feet. They already told you that the arm represents a radius. Okay? Oftentimes seeing a picture is helpful, or if you just want to write R equals 300 feet, that also works. And so now you need to find the area of how much land it covers. And so our formula would be A equals 300 squared times pi. Now, did they tell us to leave this answer in terms of pi? No. Okay, so 300 squared makes what?
90,000.
Very good. Okay, and we're just going to end up multiplying that by 3.14. I know 3.14 is not exactly accurate, but if we multiply by 3.14, then all of us will get the same answer. Okay, and so that ends up becoming what? Good, and it said round to the nearest foot, and so that's 282,600, and it's going to be feet what? Squared. Very good. Maybe it didn't say to round to the nearest foot, but we are. Okay, any questions there? All right, so now we're going to deal with the area of a sector. Okay, so what I was saying earlier is that a sector is basically like taking a piece out of the pie, okay, and they're wanting to find the area of just that piece of the circle, okay? So it's just like yesterday where you are taking the measure of the arc divided by 360 because all circles have 360 degrees, and then you're multiplying that times your area, and that is how you find the area of a sector. Okay, you're taking the piece that you want to, and then you're multiplying it by the area. Think we can handle this? Maybe? All right. So this got it problem says a circle has a radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? Leave your answers in terms of pi. So if you want to, we could draw a picture just so you can kind of see what's going on. So if you have a picture, they've told you that the radius is 4 inches, okay? And then they're wanting to find the area of this piece, and they're telling you that that arc is 45 degrees. Okay? And so what we're finding is, what is the area of this piece of the circle? Okay, so how are we going to set up the equation? Very good. So we start by 45 divided by 360, and we have to multiply that by the area. I personally like to do the area problem to the side and then just plug it in here. So over here, I'm going to do the area, and how would I find the area? What numbers would I use? 4. So 4 squared times pi. What's 4 squared? 16 pi. So my area is 16 pi. They told us to leave our answer in terms of pi, so I'm going to go over here and go times 16 pi. And remember yesterday we said we could put that over 1 just so we could visually see what was on the top of the fractions, what was on the bottom. And then we can reduce, or you can divide and multiply, however you want to do it. So if you were to divide 45 into 360, do you know how many times it goes in? Okay, and so I could cancel this out, make it a 1, and this is an 8. And can 8 and 16 reduce? Yeah, so 8 divided by 8 is a 1, and 8 goes into 16 2 times. So my answer is 2 pi what? Inches squared. Now again, you could have put 45 divided by 360 in your calculator and then multiplied by 16 to also get the answer of 2. Okay, moving on to number 3.
We should have
Okay, so I have the formula area of a sector here on the back. So find the area of each sector of the circle. Leave your answers in terms of pi. Okay, so we need to always find our area and then plug it into our formula. So on this circle, let's find our area. I'm going to give you about 20 seconds to find the area on your own. Area of that circle first. Find the area of the circle. Find the area of the circle. Okay. So, you should have written 12 squared times pi. Area is pi r squared. What is 12 squared? So we have 144 pi is my area. Okay, now I want you to set up the equation for finding the area of the sector. Okay, so how much is this sector right here? 30, good. So that means you would write 30 divided by what number? 360 times what? 144 pi. Okay, and then you can simplify. Okay, we know that the zeros can cancel. Okay, and 3 goes into 36 how many times? 12. Okay, and so then 12 goes into 144 12 times. So my answer is 12. Very good. 12 pi inches squared is the area of the sector. Okay, do we have questions there before we move on? All right, number 4. It says find the area of the sector. Using this given information, leave your answer in terms of pi. So if you're drawing a picture here, okay, since it's saying that this is TOP, we know it's circle O, so my center I'm going to label as O. I'm going to draw a picture of this. Okay, we're doing the arc PT is 135 degrees. Is that going to be a minor arc or a major arc? Minor, because it's less than 180. So we know it's going to be less than half a circle, right? And so I'm just going to draw 2 lines that I know are less than half a circle. I know it's not exactly accurate. Actually, it's very poorly drawn, but that's okay. And so that's going to be 135 degrees. It should be bigger because it's bigger than 90, right? I just didn't draw it. Okay, so this is P and T. Now, they said the diameter is 16 inches. Do we need to know the diameter? No. What do we want to know? The radius. So what would my radius be? 8. How do we get 8? We divide by 2. Very good. Okay, can you find your area of this figure? Okay, what is the formula for finding the area on this figure? Eight squared times pi, right? So we have 64 pi is my radius. Is my area. Yes. How did I get 8 for my radius? The diameter 16. Oh, okay. All right, so now how do I set this up to find the area of the sector? Good, 135 divided by 360, and we multiply that by? Very good, thank you. Okay, reduce, multiply, no. No. 24 pi inches squared is the correct answer. If you are messing up, you might want to just use the calculator. So 135 divided by 360, and then you press enter, and you get that value, and then you press times and 64, and you get exactly 24. Okay?
That's where I messed up.
24 pi inches squared. Questions? Okay, number 7. What's the area of a circle with a diameter of 16 inches? Very good. If you ever have the diameter, we can find the radius by taking the diameter and dividing it by 2, and 16 divided by 2 is 8. So here my radius is 8. What's the equation for finding area? Good. So area equals 8 squared times pi. And so that is 64 pi and then what? Inches squared. Good. Make sure you always keep your measurements. All right, find the area of the shaded region of the circle. Leave your answer in terms of pi. Okay, once you get your answer, raise your hand. This one is area of the shaded region, or area of the sector. Okay, try this one on your own.
What did I do wrong before? Because I put it in and I still got.
You put in pi. So it's leaving your answer in terms of pi. So when you're multiplying, you're not putting pi in there. So you just do 135 divided by 360, and I usually do this in steps. So do that, press enter, and then times it by just 64, and then you do 24, and then you do pi. Yeah. When it says leave your answer in terms of pi, that means don't put pi in your calculator. Oh, you just approximated?
Should we just go with this first at plug-in 75? Plug-in 75.
And don't forget your units of measurement. It's not pi squared. It's just a ton. Perfect. I don't know how to read the Starbucks this morning. Okay, and then you do
Oh, it's pi inches?
That is how big people do that.
Yeah, that's what I
I feel like I've always just called them. That's how big.
Okay, everybody that I've checked so far got it correct. Okay, so tell me how to set this one up. What should I start by doing? Start by finding the area. And so the area for this figure, what numbers would I put in? 9 squared times pi, and 9 squared is 81 pi. Next, what do I do to find the area of the sector? If this angle is 75 degrees, then that means my arc is also, so then what do I write? Times. Good. And so we can multiply, cross cancel, reduce. If you left it as a fraction, it's 135 over 8 pi inches squared. Okay? You can do stuff like dividing by 9. This makes a 9. Dividing by 9 here makes this 40. Then you could divide by 5, and you get 15, and this becomes 8. And then you can't reduce anymore. Okay? Or, as a decimal, it was 16.875 pi inches squared. If you rounded, that was okay too. Either of these answers is acceptable. Okay, do we have any questions? All right, quick write. Explain the difference between, and this goes back to yesterday, an arc measure and an arc length. What is the difference? I'd like you to write it down. I'm going to have everyone a second, and then I'll take your answer map. Okay, so Matt, what is the difference?
Arc measure is degrees, and an arc length is a fraction of the circumference.
Good. So arc measure is in degrees, and the arc length is a fraction of the circumference. Very good. It's almost like you went back to yesterday and wrote what we put. All right, any questions?